Hello everyone, here is the solution for Lab 1.3.2.9 from the course IoT Fundamentals, Big Data and Analytics from Cisco. And this lab is actually an optional exercise, but it's recommended to review your Python skills. Okay, so let's start with the first task, which is about what is 3 to the power of 5. So here we need to write a code to find the 3 to power of 5 in Python. So we use the power operator, and here we put 5, and then you can type this to run the code. By the way, to get this page, you need to download the file of the lab, and then you need to install Jupyter, and then you need to navigate through Jupyter to reach the file, and then you will get it open here if you don't have a Jupyter in your computer installed yet. Okay, so we have here the first cell, and then you can type run, and here we have the output there. Step number 2 or task number 2, create a variable called s containing the string. This course is amazing using the variable split the string into a list. Okay, so actually this is a variable here, and then we need to put this string in it. So this is the first task. Then we need to split this and create a list. So this is, if you remember from the split method, so it returns a list by default. So here what we only need to do to type s, because split will make it will return a list for for the elements. Each word is going to be represented in a separate element. So here we will have this, the first element, the second element we will have course, the third element is, and the fourth element is amazing with this exclamation mark. And each one of them will be represented in a string. So as you see here, the output. Okay, this is the split. Alright, so 3, given the variable height and mountain, use the dot format to print the following string. Alright, so first of all we need to print the following string. So we need to take the height of the empty, and then we put it there. So the height of, this is the first one, we need to put it here. Okay, let's do this this way, Control V. So the height of, now we need the height of, so actually we are using the format. So when we use the format, if you remember, we have to use the curly brackets. Then we can pass the variable to it through the format here. So the first one we are going to pass is the mountain, the variable, this one. So it's going to be here. And in the same idea, we can now use the second variable here, which is the height. Okay, and then of course we need to assign again the curly brackets one more time. So in this case we can just type, for example, here the height of this mountain is, and then we put another curly brackets, and then we type meters. Okay, so when Python will print this, it's going to be first the height of the, and then mountain, which is a variable here, which is a string empty Everest, and then is the height is going to be this number here, 8,848, and then meters. So let's check it, and you can see here the height of the empty Everest is meters. All right, now the next step is to given the following nested list, as you can see here, use indexing to grab the word this. So as you can see here, this is the list. The first element is A, the second element is B, the third element is a list. The fourth element is also a list. Alright, So to reach this, so here we have 0, 1, 2, 3. So the first one is going to be 3 because we need to grab this one here. Alright, this one. Okay, so the first one we are here in a 3. In this list here, we have like again, like we have this is the first element and the second element here. So this is an index 0 and this is an index 1. So here we have to type 1, which is the index of this list. Alright, now what we, as you already now thinking, I think there is index 0, index 1, this is index 2. So here we need to type index 2. Alright, one more thing, that this is, if you type this like without this one, it's going to work normally, no problem, because there is one element only in this list, I mean this one. But to be more precise, then you have to specify that this is at index 0. So this list has only one element, which is at index 0. So you can type it like this and then run, and then we grab the word this from the list. Okay, in step number 5, given the following nested dictionary, now we have a dictionary, grab the word that. This exercise is a little more difficult, not at all. Let's try to solve it together. Here we have the key and here we have the value. Alright, so in this value, as you can see here, we have another dictionary where there is another key here, and here we have another value. And then we have again another key, and then we have the value, so we need this one. Actually, what we need to specify first, we need to specify the key of the first dictionary, because this one is inside it. Okay, from this value here, from K1, which is the key of the first one, we need to specify like which one, or where is this dictionary here. Okay, so we can here conclude that, or we can obviously see that this is the key, and here we have another dictionary. So this is as position index 0, index 1, because this is a list, we can use index 0, 1, 2, 3. So here we have that position 3, we have another keyword, or we have another key, which is actually we. Alright, so here we have another, in the value, we have another list, which is 1, 2, 3 again. So we have to specify, 0, 1, 2, 3. So here we have to specify that there is also 3, and then we have key debar, and then we need to specify that here, which is 0, 1, 2, 3, which is again 3 here. Okay, so one more time. Here we have the key, which is K1, and then the value is about in a form of a list. So since it's a list, so we can navigate, we want to access this one, which is inside this one. So we need to reach this one first. So here 0, 1, 2, 3. So we specify that now at position 3 or at index 3, we have another list with the keyword we. And then we have a list again, so 0, 1, 2, 3. So at the position 3 again, we have another keyword, which is debar, and this is 1. And here we have this one 3 dots, so 0, 1, 2, 3, and this is the index of the word we want to reach. So let's check this one. Here you can see that K1 actually is not defined here because there is a string in a form of K1. So that's correct. Let's specify here a string again. Here we have also the same. And here we have also the same. By the way, let's also take the advantage from the error. Here we can read the error. Like here we have in cell 5, which is this one. And there we have here like K, the K is not defined. Alright, now we fix it. Let's try to run it again, and here we grabbed the word that. Okay, so what is the main difference between tuple and the list? You can type here your answer. Actually, you know the difference. Actually, the list can be modified by using the methods like append or list. In case of tuple, it cannot be changed. Alright, so tuple is immutable and list is mutable. Like dictionary is also mutable, it can be modified. List also, but a tuple is not. Create a function getDomain that grabs the email website domain from a string in the form user at domain.com. So we need to grab this only, the domain.com. Okay, let's write the code here. So here we have the definition of the function, and here we need to return something. So here, for example, let's say a text, because this function accepts one variable or one parameter, and here we are going to return the word we need. So here we have text, and then from text we need to use the method split, and then we need to specify here the split point, and this is going to here we are going to have a list with two elements. The first one is user, the second one is domain, and then you are free because you can start from -1 or you can write type 1 because it's going to user is going to be at index 0 and domain is going to be at index 1, or you can write like exit from the last one in the list by using -1. Okay, let's run this. Here again we have the same problem, that this is a special character. We wanted to specify that the string character in this format, so we need to again put this around it to tell Python that this type of text is going to be the key to split. Okay, here we have domain.com. Alright, so the next question here is 8. Create a basic function, find internet function. This is the name of the function that returns true if the word internet is contained in the input string. Don't worry about the edge case, like punctuation being attached to the word, the account for capitalization here if you need more information. However, let's do this function together. This function also accepts one string. Let's call it also text. And then it's going to return the word internet, and of course we type here the text and then we split this one. Alright, so here is going to have the function. This is the function invocation. The Internet Engineering Task Force was created in 1986, and it's going to be here. First of all, we are going to change the all the text into small letters, so to match the internet, and then split the spaces. And when internet is going to be the same, then it's going to be true. And here we should see true actually. Let's run it, and here we true. If I delete this word and run it again, I should see false. Okay. And question number 9, here we also need to create a function, count IoT. This is the name of the function that counts the number of times the word IoT occurs in a string. Ignore edge case, but take into account a capitalization. Alright, so here we need to define this function, and as you can see here, we need to you have to write 1, 2, 3, 4 lines only. Okay, so first we need to count. So the first thing is to have a counter, and then the counter is 0 at the beginning, and then okay, let's do this here. Okay, and then we are going to have this text, which is here called st, and then we go through each one of them. If we will find IoT in it, then we increase the counter by 1. So since we are going to iterate between them, so we are going to use the for loop, and then forward and st again dot power, because we need to ignore the if one of them is capital letter, and then we use another method called split, and then we search if there is a word equals IoT, then in this case, so the counter plus equal 1. And at the end of this function, like we are going to, of course, going to return the counter. We already written here. Okay. So we define the function. This is the name of the function. This is the counter. And this is the for loop. Here we are going to go through each of these words, and we change them into a list. And then we go if word in equals IoT, then increase the counter by 1. So here we should see like this is 1, this is 2, this is 3, and this is 4. So we should see for number 4, and this is the number here. Okay, if I'm going to delete this one also, this one also, and this one, which is C0. Alright, it's working fine. Let's move to question number 10, which is about use lambda expressions and the filter function to filter out words from a list that do not start with the letter D. For example, here we have data, here we have salt, diary, cat, dog, so we should have the output data, diary, and dog. Okay, so here is the list, and here we have to like specify the filter function, which is already written here, and here again, as you already see, then we need to use the lambda. And as you already know, the lambda takes, here in this case we need one parameter, which is, let's call it word, and then it's going to return the word like starting for the first one with letter D, then we pass the list. So here was going to, this filter is going to take the first function and the list and apply this list to this function. And as you already know, this should be a list tuple, like you can use it anything that it can be iterated. Okay, so let's now we should see data, diary, and dog. Here we have sip, sorry, not sick. So let's fix this again, run it again one more time, and here we have the output. And this is the filter function, which accepts like first parameter as a function, and the second one as the iteratable structure or data structure. Okay. Here in question number 11, use lambda expressions and the map function now to convert a list word to uppercase. For example, here we have data, salt, diary, cat, dog, so we should have the output something like this. Okay, again here this map function also does the same. It accepts the first one is a function and the second one is a like a data structure that can be either like list or tuple. Okay, so here we first of all we need to specify the lambda function. Again, here we have word, And now for the word let's only use the upper for each word in this list. We are going to take each one of them and then we change it to the upper. And what we need also to do this, then we just put a print here. Okay, so we should see the output like this. Okay, here we have a problem. The problem that we are trying to print the output of this, which is not acceptable. As you can see here is only a reference to the memory. So we should print the list itself, which is SQ. Then we type here print. Right now it's okay, but it's not in a form of upper. Okay, the problem is here. We should specify. Okay, we have another problem. Let's see, there is a lambda. Okay, and here we should specify that this sequence is going to be the effect of this function. Yes, now I think it's going to be correct because now we did this and the output is going to be in the list called sequence, and then we print the sequence and then we print the sequence. Now it's fine. So like here also we did it in this way. So let's try to delete both of them. Then run it again. Now it's also good. However, you can do this way or you can do the one like this. You receive the output of this in a variable and then you print a variable. Here you can sequence 2, for example, or sequence let's say big. Okay, let's run it. Okay, so here we have the output there. Okay, and question 12, imagine a smart thermostat that is connecting to a door so that it can detect, in addition to the temperature, when people enter or leave the house. Write a function that if the temperature is lower than 20 degrees Celsius and there is a people in the house, and there are people in the house, encoded as a Boolean value to be passed as a parameter to the function. Turn on the heating by returning the string heating on. When the temperature reaches 23 degrees or there are no people in the house, it returns the string heating off, and when none of these conditions are met, the function returns do nothing. Alright, so now I think you already can do this task, but let's do it also together. Here we have a function and here we return the return function. The command, so first of all we have a command. In the case of command, we are going to return heating on or heating off or do nothing. So the do nothing, this is the first initial value, which do nothing. Alright, then as you can see, this function accepts two parameters. The first one is the temperature, the second one is people in. And according to the first condition, which is if the people in and temperature less than 20, then we can change the command to be like heating on. Okay, so the people in here is about a boolean. it's mentioned here, it's a Boolean one. So if it's true or false, so if people in is true and the temperature less than 20, then heating on. Okay, else, or also we have another if statement, if the temperature is bigger or equals 23, or of course here not people in, then there are no people in the house, then in this case the command is going to be heating off. And then we return the command. Okay, so this is the function here. Now let's try to call the function, then verify. Let's run this. Now let's try to verify. Here we not verify the function. Here we have a function invocation with 21 and true. So 21, and there is the true here. So we should see do nothing, because the condition is nothing there, because people in and the temperature is 21, which is nothing we need to do. So let's run this one. Okay, the second one here, the 21 and false. So we should see here actually, so the temperature is bigger than 21, but in this case there are no people in the house, so we should see it heating off. Okay, when we change this to true, we should see heating on. Okay, now this should be 18. Then we run it again and then heating on here. Alright, so the function is working fine. Okay, so let's move forward to next task, which is about 13. The function zip list1 and list2 returns a list of tuples, okay, where the ith tuple contain the ith element from each of the argument lists. Use the zip function to create the following list of tuples. So here we have a list, and then what we actually need to do is to create a list of tuples, something like this. Alright, so what we can see from here, from parking is going to be in the -1, and this is going to be a tuple, and the shops the shops should be in 0. This is the floor 0, and then we have food court, and we have 1, and then the second one is the offices is for floor 2. Okay, so here we need to just do the function here. We have list, okay, and then we need to use the function zip. Then we need to specify the first one is the floor types, and of course with the floor numbers. So Python is going to take this way. Parking is going to be -1, shops is going to be 0, food court is going to be 1, food court, and then the office is going to be 2. Okay, let's run this one here, and here is the list what we wanted. Alright, let's move forward to the next question here, which is about using also the same function, which is use the zip function and dictionary to create a dictionary, elevator dictionary. This is the name of the dictionary, where the keys are the floor types and the values are the corresponding floor number. So that is going to be -1 is the parking. Alright, so the same idea here. We need to create a dictionary, which in this dictionary is going also again to use a zip. And inside there we should specify, actually here we need the first specify, since it's -1, so the key is going to be this one. and the value is going to be one of these elements in the list. Okay, so let's run this one, and here we have what we need. And then let's run now this one, and here we have parking with dictionary -1. Parking, if I change it to 0, I should see shops. Okay. In question 15, here we have to create an elevator class. The constructor accepts the list of strings, floor types, and the list of integers floor numbers. The class implements the methods ask which floor and go to floor. The output of this method should look as follows. Alright, so the output should be something like this. Here when we have elevator floor number and floor type, and then we go to 1, we should see the output going to the food court floor, and then when we type -2, then there is a floor number -2 in this building, and then when we type office or offices, then we should see the floor offices in the number 2, and so on. Alright, so let's write the class together here. So here we have the definition of the class. Here we have the constructor accepts 2 parameters, and then we have the first one here, the floor numbers, which is the first one, and the second one is the floor types, which is the second one here. And here we have a dictionary of number to type, so floor number and the floor type, and then we have type to numbers dictionary, and here we have the floor here and the opposite, and then the floor. And then we have the function here called ask which floor, and then accept the floor type. And if the floor type is in the self like floor types here, which we created there, then we print the floor, which is the floor type. The floor is a number, which is actually is going to be here the like type to number dictionary, and this one here. Otherwise print that there is no floor type, which is in this case here this variable here in this building. Okay, so we need to define another function called go to the floor, and then we see here that accepts like the floor number. Alright, so let's try to copy this one and modify it down. Okay, and instead of floor type here, we need to type floor number, because we are now going to do the opposite of the function ask which floor. So if the floor number is in the self floor number or numbers, then print like here let's try to type something like going to, or going to, let's put here curly bracket, and then floor, and here we need to specify the format self. It's going to be first here. Okay, let's delete this one, and let's take like number to type, this one, and put it here, the first element there. And then what we need to specify here is the value to floor number, and then okay, so floor number, if floor number is in self floor numbers, which is actually there, this one here, Then we are going to specify which one is going to go, which is number to type dictionary, which is this one here. And then we specify actually which one. This is the dictionary name, and here is the key for it. All right. If there is nothing, like if there is no floor number, in this case we are going to print there is no floor number. Let's type here floor number, and then this building. And here we specify, of course, the format floor number. All right, let's take a look on it one more time. Here we have the class which accepts actually the floor number and accepts the floor types. The floor number here is going, we already our floors numbers, which is in range from -1 to 2, and the floor types is a list. All right. Yes, so floor numbers, here is we can specify that this is a range from -1 till 2, and here we have a list. Okay, for the floor numbers, we put it here in this variable, and then the floor types, we put it here in this variable inside the, as you can see, this is a hidden. And then we have we created two dictionaries. The first one is about the floor numbers, which is in the range, and the output here floor types, which is the first one. And then the second one is type to number, which is the floor types now with the floor number. So we have two dictionaries. The first one, floor number with floor type. So for example here -1 park, and here we have park -1. So just an opposite. And here we have two functions. If we are going to ask which floor, actually since it's inside the class zone, we can call it method. So ask which floor, which accepts type of floor or floor types. Okay, and then we check now, according to this, we are going to check this dictionary here. If it's not, then we print something that this is there. And the second one accepts only the floor numbers and goes and searches for the floor number in this dictionary. Okay, let's try to run it. And here we have to verify the code and is working correctly. So here we have floor number. There is the object called EL, and here we have the class with the floor numbers and floor types. Okay, and then we have EL, the floor numbers and floor types there. We already saw them here. And here we have go to floor 1. Alright, so which one is the floor 1? Let's go back and check. Floor 1 is the food court. Okay, let's see if there will be a food court. Okay, so going to the food court. Here we go to -2. According to this, -2, we don't have -2 here. It starts from -1. So the output here should be like there is no floor, something like this. There is no floor, so the output is this one here. Okay, let's go now to offices. Let's check the office, which one here. It is going to be in floor 2, so the output should be 2 here. The office's floor is at number 2, and here we have swimming pool, which is actually we don't have swimming pool here. So also we should see something now that there is no swimming pool in this building. Okay, so this is the end of this lab. I recommend you to do the lab by yourself again to practice, and if you will have any questions, please feel free to bring them to the lab. Thank you and see you next video.